Look up at the night sky. What do you see? Twinkling stars, a distant moon, maybe a planet or two? Now imagine looking beyond. Imagine a place where stars are born, where galaxies collide and black holes devour everything in their path. This is the universe we live in, a place of immense scale, breathtaking beauty, and endless mystery. We humans have always been explorers. It's a journey that takes us far beyond our own planet, out into the vast expanse of space and time. So join me as we embark on a journey of cosmic exploration. Before we dive into the depths of the universe, let's take a moment to consider our place in it. We live on a planet called Earth, a small, rocky world orbiting a rather average star we call the Sun. Our Sun is just one of billions of stars in the Milky Way galaxy, a vast, swirling city of stars, gas, and dust. But the Milky Way is just the beginning. Our galaxy is part of a group of galaxies called the Local Group, which in turn is part of a larger supercluster of galaxies. And these superclusters are strung out across the universe like beads on an invisible cosmic web. So when we talk about the universe, we're talking about everything. All the matter and energy that exists, from the smallest subatomic particle to the largest galaxy cluster, all bound together by the fundamental laws of physics. It's a mind-boggling concept, one that stretches the limits of our imagination. But it's also incredibly humbling to realize that we are a part of something so much greater than ourselves. One of the most challenging things about comprehending the universe is grasping its immense scale. Our brains are wired to understand distances we can walk, time spans we can experience, but cosmic distances and timescales are on a whole other level. Consider the speed of light, the fastest speed anything can travel in the universe. Light from the sun takes about 8 minutes to reach Earth. That means we're seeing the sun as it was 8 minutes ago. Now imagine looking at a star that's thousands of light years away. You're seeing light that left that star thousands of years ago, long before our civilization even existed. And when we look at distant galaxies, billions of light years away, we're looking back in time to the early universe. It's like having a time machine, allowing us to witness the evolution of the cosmos firsthand. The universe is not a static, unchanging place. It's a dynamic, ever-evolving entity, full of motion and change. Galaxies are constantly moving, some colliding with each other in spectacular displays of cosmic fireworks. Stars are born, live out their lives, and eventually die, sometimes in dramatic explosions called supernova that can outshine entire galaxies. Black holes, those enigmatic objects with gravity so strong that not even light can escape, lurk at the centers of galaxies, shaping the fabric of space-time itself. And then, there's the expansion of the universe itself. Every galaxy is moving away from every other galaxy, like dots on a balloon being inflated. This expansion tells us that the universe is not static, but rather it's constantly evolving and changing. It's a cosmic ballet on a grand scale, a dance of creation and destruction that has been playing out for billions of years. And we have the privilege of witnessing it, of piecing together the story of our universe and our place within it. Our journey begins with a question that has captivated humanity for millennia. How did it all begin? The universe, in all its vastness and complexity, must have had a starting point. But what was that starting point, and what came before it? For centuries, these questions were the domain of philosophers and theologians. But in the 20th century, science began to provide some tantalizing answers. The prevailing scientific theory for the origin of the universe is the Big Bang Theory, a model supported by a wealth of observational evidence. The Big Bang Theory doesn't tell us what caused the universe to come into being, but it does describe what happened in the first moments after that initial event. It paints a picture of a universe that was once incredibly hot, dense, and rapidly expanding. Imagine, if you will, a universe compressed into a point smaller than an atom. This point, called a singularity, contained all the matter and energy that would eventually become everything we see around us. Then, about 13.8 billion years ago, something extraordinary happened. The singularity began to expand. This wasn't an explosion in the traditional sense, like a bomb detonating in space. Instead, it was the expansion of space itself, an inflation that continues to this day. As the universe expanded, it cooled, and energy began to transform into matter, following Einstein's famous equation, E equals mc squared. In the first fraction of a second, the universe was a seething cauldron of subatomic particles and radiation. It was a time of intense energy and rapid change, a period known as the Planck epoch, about which we still know very little. But as the universe continued to expand and cool, conditions gradually became favorable for the formation of more familiar structures. As the universe expanded and cooled, the primordial soup of particles began to thin out. Temperatures dropped, and the energy levels of the universe decreased. This cooling allowed for the formation of the first atoms, primarily hydrogen and helium, the simplest and most abundant elements in the universe. These early atoms were not evenly distributed. Tiny variations in density, present even in the very early universe, acted as seeds for the formation of larger structures. Gravity, the weakest of the fundamental forces but relentless in its pull, began to draw these atoms together. Over millions of years, these clumps of matter grew larger and denser, eventually collapsing under their own gravity to form the first stars. These stars, massive and short-lived, would play a crucial role in the evolution of the universe, forging heavier elements in their cores and seeding the cosmos with the building blocks of planets and life itself. Section 4. Echoes of Creation, the Cosmic Microwave Background. The Big Bang Theory, while compelling, wouldn't be widely accepted without strong observational evidence. One of the most important pieces of evidence comes from the faint afterglow of the Big Bang itself, the cosmic microwave background radiation. This radiation, discovered in 1964, is a faint hum of microwaves coming from every direction in the sky. It's a snapshot of the universe as it was just 380,000 years after the Big Bang, a time when the universe had cooled enough for atoms to form and light to travel freely. The cosmic microwave background provides a wealth of information about the early universe, confirming key predictions of the Big Bang theory. It tells us about the universe's age, its geometry, and the relative amounts of matter and energy it contains. It's a testament to the power of science to probe the distant past and unravel the mysteries of our cosmic origins. Section 1. Stellar Nurseries, the Birth of Stars. Stars, those twinkling beacons in the night sky, are not eternal. They are born, live out their lives, and eventually die, often in spectacular fashion. Their birthplaces are vast, cold clouds of gas and dust scattered throughout galaxies, known as nebulae. These nebulae, often called stellar nurseries, are the sites of intense star formation. Gravity plays a key role, drawing the gas and dust together into denser and denser clumps. As these clumps contract, they heat up, eventually reaching temperatures and pressures high enough to ignite nuclear fusion in their cores. This ignition marks the birth of a star. The outward pressure from nuclear fusion balances the inward pull of gravity, creating a delicate equilibrium that allows the star to shine for millions, billions, or even trillions of years. Our own sun, a middle-aged star, formed in such a nebula about 4.6 billion years ago. Section 2. Cosmic Alchemy, the Lives and Deaths of Stars. A star's life is a constant battle between gravity and nuclear fusion. Gravity relentlessly tries to compress the star, while nuclear fusion in the core creates outward pressure that counteracts this inward pull. The star's mass determines its fate, dictating how long it will live and how it will eventually die. Smaller stars, like our Sun, live for billions of years, steadily fusing hydrogen into helium in their cores. Once they exhaust their hydrogen fuel, they expand into red giants, engulfing any nearby planets. Eventually, they shed their outer layers, leaving behind a dense, Earth-sized core called a white dwarf. More massive stars live shorter, more dramatic lives. They burn through their fuel much faster, fusing heavier elements in their cores. These stars eventually explode as supernovae, briefly outshining entire galaxies. These explosions scatter heavy elements into space, seeding the cosmos with the ingredients for planets and life. Section 3. Islands of stars, galaxies, and their evolution. Stars are not randomly scattered throughout the universe. They are grouped together in vast, gravitationally bound systems called galaxies. Our own Milky Way galaxy, a barred spiral galaxy, is just one of billions of galaxies in the observable universe. Galaxies come in a variety of shapes and sizes, from majestic spirals like our own to elliptical galaxies with smooth, featureless shapes. They are dynamic entities, constantly evolving through interactions with other galaxies. Galaxy collisions are spectacular events, triggering bursts of star formation and fueling the growth of supermassive black holes at their centers. These collisions play a crucial role in shaping the large-scale structure of the universe, creating clusters and superclusters of galaxies. Section 4. The Cosmic Abyss, Black Holes and Their Enigmas. Black holes are among the most fascinating and enigmatic objects in the universe. They are regions of space-time where gravity is so strong that nothing, not even light, can escape. They form when massive stars collapse at the end of their lives. The boundary of a black hole is called the event horizon, the point of no return. Once something crosses the event horizon, it is forever trapped within the black hole's gravitational grasp. Black holes, despite their invisible nature, exert a powerful influence on their surroundings. They can disrupt the orbits of nearby stars, devour gas and dust from their surroundings, and even warp the fabric of space-time itself. Their study provides insights into the nature of gravity and the fundamental laws of physics. Section 5. Planetary Wonders. Our solar system and beyond. Our solar system, a collection of planets, moons, asteroids, and comets orbiting our sun, is a microcosm of the universe's diversity. From the scorching heat of Mercury to the icy plains of Pluto, each world offers a unique glimpse into the possibilities of planetary formation and evolution. Our own planet, Earth, stands out as a haven for life, with its temperate climate, liquid water, and protective atmosphere. But the search for life beyond Earth is one of the most compelling endeavors of modern science. The discovery of exoplanets, planets orbiting stars other than our sun, has revolutionized our understanding of planetary systems. These discoveries range from gas giants larger than Jupiter to rocky worlds in the habitable zones of their stars, where conditions might be right for liquid water and even life as we know it. Our exploration of the universe has led us to a startling realization. Most of the cosmos is invisible. The stars and galaxies we see make up only a tiny fraction of what's actually out there. The vast majority of the universe is made up of something we can't see. We call this dark matter and dark energy. It's a humbling thought revealing a universe far stranger and more mysterious than we ever imagined. The first hints of dark matter's existence came from observations of galaxies. Astronomers studying the rotation of spiral galaxies noticed something peculiar. The stars in these galaxies were moving faster than they should have been, based on the amount of visible matter alone. It was as if some unseen force was holding these galaxies together, preventing them from flying apart. This invisible gravitational glue came to be known as dark matter. We can't see it directly, but we can infer its presence from its gravitational effects on the visible universe. It's like knowing someone is in a room because you can see the chair they're sitting in move, even if you can't see the person themselves. Further evidence for dark matter comes from the cosmic microwave background, the faint afterglow of the Big Bang. The pattern of temperature fluctuations in this radiation suggests that dark matter makes up about 85% of the matter in the universe. This invisible substance, it seems, played a crucial role in the formation of galaxies and the large-scale structure of the cosmos. If dark matter is the invisible glue holding the universe together, then dark energy is the mysterious force pushing it apart. In the late 1990s, astronomers made a startling discovery. The expansion of the universe, long thought to be slowing down due to gravity, was actually accelerating. This discovery, which earned the researchers the Nobel Prize in Physics, implies the existence of a form of energy that permeates all of space, counteracting the pull of gravity and causing the expansion of the universe to speed up. This energy, which we don't fully understand, is what we call dark energy. Think of it like this. Imagine throwing a ball up in the air. You'd expect it to slow down as gravity pulls it back down. But what if, instead of slowing down, the ball started moving upwards faster and faster? That's what's happening with the universe. And dark energy is the mysterious force responsible for this cosmic acceleration. Section 4. Grappling with the unknown. The discovery of dark matter and dark energy has revolutionized our understanding of the universe. But it has also raised more questions than answers. What are these mysterious substances made of? What are their properties? How do they interact with the visible universe? Scientists are working tirelessly to find answers. They are building more powerful telescopes and designing experiments to detect dark matter particles. The quest to understand dark matter and dark energy is a journey into the unknown. Section 5. The quest for answers continues. The universe is full of surprises. Just when we think we understand, we find something new, challenging our knowledge. Dark matter and dark energy remind us of the universe's mysteries, with secrets waiting to be unlocked. The quest is global, involving scientists worldwide. From subatomic particles to cosmic structures, the universe will continue to surprise us. It's a journey without end, and we are all a part of it. Section 1. Are we alone? The search for life beyond Earth. One of the most profound questions we can ask as human beings is this: are we alone in the universe? It's a question that has captivated our imaginations for centuries, inspiring countless stories, myths, and scientific inquiries. The vastness of the cosmos, with its billions of galaxies, each containing billions of stars, suggests that life, even intelligent life, might exist elsewhere. But finding evidence of extraterrestrial life is no easy task. The distances between stars are immense, making it challenging to study even the closest star systems in detail. And even if life does exist on other planets, it might be so different from our own that we wouldn't even recognize it. Despite these challenges, the search for extraterrestrial life is one of the most exciting and important scientific endeavors of our time. It's a search that takes us beyond the familiar confines of our own planet and forces us to confront fundamental questions about the nature of life, the origins of the universe, and our place in the grand cosmic scheme of things. The cosmic haystack, seeking signs of life. Finding life beyond Earth is often compared to searching for a needle in a haystack. The universe is vast, and the conditions required for life as we know it are relatively specific. We need liquid water, a source of energy, and a stable environment for life to thrive. To narrow down the search, scientists are focusing on planets that orbit within the habitable zones of their stars, where temperatures are just right for liquid water to exist on the surface. They are also looking for signs of biosignatures, chemical compounds or patterns in a planet's atmosphere that could indicate the presence of life. These biosignatures could include gases like oxygen, methane, or ozone, which are produced by living organisms on Earth. By analyzing the light that passes through an exoplanet's atmosphere, astronomers can identify the presence of these gases and learn about the planet's atmospheric composition. It's a challenging task, but advances in telescope technology are making it increasingly possible. Worlds beyond our sun, the exoplanet revolution. Our understanding of planetary systems has been revolutionized with the discovery of thousands of exoplanets, planets orbiting stars other than our sun. These discoveries have revealed an astonishing diversity of worlds, from gas giants larger than Jupiter to rocky planets similar in size and mass to Earth. Some of these exoplanets orbit within the habitable zones of their stars, suggesting they could harbor liquid water. A universe of possibilities. The search for extraterrestrial life is ultimately a search for ourselves. It's a quest to understand our place in the universe, to know if we are alone or if life is a common occurrence in the cosmos. The answer to this question, whatever it may be, will have profound implications for our understanding of life, the universe, and everything. Even if we never find definitive proof of extraterrestrial life, the search itself is a worthwhile endeavor. It pushes the boundaries of our knowledge, inspires our imaginations, and reminds us of the vastness and mystery of the universe we inhabit. And who knows, maybe one day we'll find ourselves looking up at the night sky, no longer wondering if we are alone, but knowing that we are part of a grand cosmic community of life. As we conclude our journey through the cosmos, from the fiery birth of the universe to the search for life beyond our planet, one thing remains abundantly clear. The universe is a place of endless wonder and boundless mystery. Every answer we uncover only leads to more questions, fueling our curiosity and driving us to explore further into the vast unknown. We've peered into the hearts of distant galaxies, witnessed the birth and death of stars, and grappled with the enigmatic concepts of dark matter and dark energy. We've discovered thousands of planets orbiting other stars, some of which may harbor the right conditions for life as we know it. Yet with every new revelation, we are reminded of how much more there is to learn. The universe does not readily reveal its secrets. It takes time, patience, and the relentless pursuit of knowledge to unravel its mysteries. But the rewards are immeasurable. Each discovery, whether big or small, brings us closer to understanding our place in the grand cosmic tapestry. Contemplating the vastness of the universe and the intricate workings of the cosmos can be a humbling experience. It forces us to confront our own insignificance in the grand scheme of things. Our planet, our solar system, even our galaxy, are but tiny specks of dust in the grand cosmic arena. Yet, this realization should not make us feel insignificant. On the contrary, it should empower us. We are a part of this universe, connected to it in ways we are only beginning to understand. The very atoms that make up our bodies were forged in the hearts of stars that died billions of years ago. We are, in a very real sense, children of the cosmos. Embracing this cosmic perspective allows us to see beyond the boundaries of our own planet and appreciate the interconnectedness of all things. It reminds us that we are not alone in the universe, and that our actions have consequences that extend far beyond our immediate surroundings. As we look to the future, the possibilities for space exploration and discovery seem limitless. We are developing new technologies that will allow us to study the universe in greater detail than ever before, from powerful telescopes that can peer into the hearts of black holes to spacecraft that will search for signs of life on distant moons and planets. We are also on the cusp of a new era of human spaceflight, one that will see humans venturing beyond low Earth orbit and establishing a permanent presence on the moon and beyond. These missions will not only advance our scientific understanding of the universe, but will also inspire generations to come and pave the way for a future where humanity is a multi-planetary species. This future, however, is not guaranteed. It requires our continued investment in science, technology, engineering, and mathematics education. We need to inspire the next generation of explorers, thinkers, and dreamers who will push the boundaries of human knowledge and help us unlock the secrets of the universe. The universe is more than just a collection of stars and galaxies. It is a source of endless inspiration, sparking our imaginations and challenging us to think beyond the limits of our everyday lives. From artists to musicians, writers to filmmakers, the cosmos has served as a muse for countless creative endeavors. Consider the works of science fiction authors like Arthur C. Clarke and Isaac Asimov, who envisioned a future where humanity ventured among the stars, encountering alien civilizations and grappling with the ethical dilemmas of interstellar travel. Their stories, while fictional, have inspired generations of scientists, engineers, and dreamers to pursue careers in space exploration and push the boundaries of what's possible. The universe also serves as a reminder of the power of human ingenuity. and our ability to overcome seemingly insurmountable challenges. When we look back at the history of space exploration, from the first Sputnik satellite to the Apollo moon landings, we are reminded that nothing is impossible if we dare to dream big and work together towards a common goal. So the next time you find yourself gazing up at the night sky, take a moment to appreciate the vastness and beauty of the universe we inhabit. Remember that we are part of something much greater than ourselves, a cosmic story that began billions of years ago and continues to unfold today. Never stop asking questions, never stop exploring, and never stop looking up, for the universe is full of wonder and discovery for those who dare to seek it out.